I'm sharing my screen, students. Just check and let me know if it is visible.
Yes, sir.
Okay. So am I audible to all of you?
Yes, sir.
Yeah. So very good morning, students. In the last lecture, we were discussing about selection sort technique, and in selection sort, we have seen the numerical of how to sort the given elements using selection sort. So the philosophy of selection sort is that selection sort takes n minus 1 iterations for sorting purpose, and in every iteration we pick the smallest number from the input and place it in its appropriate position. Now here the problem will get reduced by 1 from left hand side after end of each iteration. So in the first iteration, we find the smallest number at index number 3. So we swap index number 3 with index number 0. Then the problem is reduced from left hand side. So our problem is now from index number 1 to index number 6, from which we find the smallest number at index number 2. So we swap index number 1 element with index number 2 element in the second iteration. Then in the third iteration, we ignore the first two numbers, and then the problem is from index number 2 to index number 6, in which we find the smallest number at index number 6. Then we swap index number 2 with index number 6. This process continues for n minus 1 iteration, that is 6 times, and the final result we get is the sorted input. Based on this, I had given you to solve one numerical for 21, 17, 16, 9, 22, 15, 10, 14 and 11. I hope all of you must have solved this. This particular numerical had total 9 elements. So you'll have 8 iterations in that. You'll have 8 different min values. Okay. So can anyone tell me what was the first min value that you got?
3.
3 was the first min value. So there was a swap that happened between 9 and 21. Rest numbers remain as it is. What is the next min value that you found? Am I audible, students?
6.
6 was the next min value. Okay. So a swap was there between those two elements. Rest of the elements remained as it is. Next step, what was the next min?
8.
8. 8 was the next min index. So between 11 and 16 would have happened. Other elements remained as it is. The first three elements are sorted now. Next min was
7.
7. So there was a swap between 17 and 21. Rest elements remain as it is. Yes, next smallest element is at
5.
Did I make any mistake in writing? Wait. So this is 9, 10, 11, In 16, middle numbers remained as it is. Okay, so this has got sorted now. Now it is 7. So 14 will be swapped with 21. Middle numbers will remain as it is. Yes, what is the next index? What is the next min?
Fifth index.
Fifth index is the next min. 15 and 22. Other numbers remain as it is. Do we have roll number 12? Roll number 12?
Yes, sir.
What is the next min?
8.
8. Okay, so 16 and 22. Do we have roll number 51? Roll number 51. Are you present? Roll number 51. Roll number 51 is present. Am I audible, students?
Hello, sir. Yes, sir.
Yes.
Yeah, roll number 51.
Hello, sir.
Yes.
Sir, screen दिसत नाहीये, sorry.
So when you will tell that screen is not visible? After lecture is
Sir.
completed?
Sir, इथं जरा range issue आहे त्याच्यामुळे.
So you tell me the answer na. We are into now 7th step. So you have solved the numerical in your notebook, right?
Yes, sir.
So in 7th iteration, what is your mean?
17.
7th iteration, what is the value of mean? It is 6. 7th iteration value is mean is 6. It is index. 17 is the number, correct? Okay. So there will be a swap that will take place between. So here no swap will take place because 17 itself is smallest number, right? So here swap will not take place. So this number will be repeated as it is. This is our 17, which is now sorted. Then we have 21. Roll number 30. Rohit Patil. Roll number 30.
Yes, sir.
Yeah, what is the next min?
7.
7. So 21 again, this is not required to be sorted because it is already in its appropriate position. And finally 22 means this will be done. So this is our last iteration. I hope all of you have understood this numerical. Anyone is having any doubt in selection sort numerical? All of you have verified these results with your notebook. Roll number 3, Abhishek.
Yes, sir.
You have got the same type of answer.
Yes, sir.
Okay, roll number 49, Mudassir. Total
Yes,
number
sir.
40. So have you got this same type of answers in your selection sort?
Yes, sir.
Okay. Okay. So my dear students, now let us see the logic for this selection sort. Okay. So in this selection sort, as I told you, that there are total n minus 1 iterations. Okay. And similar type of n minus 1 iterations were also there in our bubble sort. So if you remember how we had written the for loop for number of iterations in bubble sort also, a similar for loop I am writing here for selection sort. So for I is equal to 0, I less than n minus 1, I plus plus. So if your value of n is say 7, so 7 minus 1 will become 6. I less than 6 means maximum possible value for I will become 5, and you'll get 6 possible values like 0, 1, 2, 3, 4, 5, which will be your 6 iterations. Which will be your 6 iterations. Okay, so this for loop, outer for loop, is for number of iterations. But what is different here in case of selection sort is the inside logic. Now here inside we are not doing a push kind of thing or a pull kind of thing. Okay, like we did in case of bubble sort. Excuse. There every time the swap used to happen. Here what we need to do is, here we need to find the location of min. Here we need to find the location of min. And at the end, after we check with respect to all other numbers, whatever mean value we get, we have to swap that mean value with that particular appropriate number in that particular iteration. So in first iteration, we'll swap it with 0, second iteration, we'll swap it with 1, and so on. So if we talk about iterations, okay, if we talk about iterations, what will be the value of I when we are in first iteration? Value of I will be 0. In second iteration, value of I will be 1, then 2, then 3, then 4, right? Then 5, then 6, then 7. This is how our value of I will change, right? This is how our value of I will change. Are you understanding this, students? Okay, so these are our total 8 iterations, which are indexed in the form of I from 0 to 7. Which are indexed for I in the form of 0 to. So what are total number of values? Total number of values are 8. So total 8 iterations are there. How many numbers are there total? Total 9 numbers are there. So 8 iterations in the I in the form of 0 to 7. Now in each iteration we are supposed to find this mean. If I find this mean, suppose if I find mean as 3 in my first iteration, because my smallest number is 9, then I have to swap this A of 3 with A of 0. Right? A of 3 means what? A of min, because we have found that min, right? A of min, we have to swap with A of 0 in the first iteration. Next iteration min is 6. We have to swap A of 6, that is A of min, with A of 1. Then next time A of min with A of 2. Then next time A of min with A of 3. Then next time A of min with A of 4. Right? So indirectly what we are doing, we are swapping A of min with A of I. Correct? What is the value of min in first iteration? 3. So A of min is what? 9. That we swap with A of I. What is value of I? It is 0. Right? So A of 3 and A of 0 got swapped in our answer. Right? In second iteration, what is value of min that we calculated? 6. So we swap A of min with A of I. So A of 6 with A of 1. That is nothing but 17 and 10 will get swapped. Are you getting this, my dear students? So once we find the min, what we do is we do a swap of A of min with A of I. We do a swap of A of min with A of I, because now I is incrementing in our iteration. So in first iteration, the swap happens with 0th location. In next iteration, swap happens with first location, and so on. The journey continues, right? Now the major task is to find this mean. Major task is to find this mean, right? So how we find this mean? In first iteration, what we do? We assume initially that 21 is smallest. So initially what I'll do? Initially I'll assume that mean is 0. Initially I'll assume that mean is 0. Then I'll start comparing A of 1 with A of min, then A of 2 with A of min, then A of 3 with A of min, A of 4 with A of min, A of 5 with A of min, A of 6 with A of min, A of 7, and then finally A of 8 with A of min. So I compare all the numbers from next position till last number. with mean. And if I find a new smaller value, I update my mean, right? So initially I assume that mean to be 0. So if we see how this 3 got calculated, if we see the bifurcation of this 3, first we assume mean as 0. Then we compare a of 1 with a of mean. So whether 17 is less than 21, yes. Then I make my mean as 1, right? Then again I compare whether a of 2 is less than a of mean, whether 16 is less than 17, yes. So again I update my mean to 2. Then again I compare a of 3 with a of mean, whether 9 is less than 16, yes. So again I update my mean to 3. Again I compare whether a of 4 is less than a of mean, whether 22 is less than 9, no. So I will not update. Again I'll compare whether a of 5 is less than a of mean, whether 15 is less than 9, no. So again I'll continue, mean will not change. Again I'll check whether a of 6 is less than a of mean, whether 10 is less than 9, no. So I'll not change my mean. I'll again continue whether a of 7 is less than a of mean, whether 14 is less than 9, no. I will not change my mean. Again I'll continue whether a of 8 is less than a of mean, whether 11 is less than 9, no. So I'll not change my mean. And this is how I find my final value of mean as 3. This is how I find my final value of mean as 3. So initially I assume my mean to be 0 in first iteration, correct? In second iteration, what I do? Initially I assume my mean as 1 because now problem has reduced from left hand side, correct? So indirectly, what is the initial value of mean that I assume? In first iteration it is 0, in second iteration it is 1, in third iteration it is 2, in fourth iteration it is 3, and so on. So indirectly the initial mean value that I assume is I only, correct? So that I'll write here in the form of code that initial value of mean is I. Initial value of mean is I. So if I am in my first iteration, value of I is 0, I assume my mean to be 0. I assume my mean to be 0. Then I start checking this value for all the next values. From where? From next position of I. So initial value for j now is I plus 1. So where the loop of j will start? So if we are in our first iteration, right? Value of I is 0. Value of I is 0, right? Value of I is 0. Next, we assume mean to be 0. We assume. Then we start comparing all the numbers from 1 to 8. We start comparing all the numbers from 1 to 8. So what is 1? It is I plus 1. If your I is 0, j will start from 1. Correct? If you are in your second iteration, that time your I will be 1. Your j loop should start from 2. Are you getting this, my dear students? In the third iteration, your value of I will be 2. So your j should start from 3. Because in that case, we don't need to consider these numbers which are on left hand side because our problem is getting reduced. So now my j loop is starting from I plus 1. My j loop is starting from I plus 1. Okay, so if we are in the first iteration, value of I is 0, j loop will start from 1 and it will go till 8. Correct? In the second iteration, my initial value of I will be 1. The j loop will start from 2 to 8. In my third iteration, initial value of I will be 2. J loop will start from 3 to 8. In the fourth iteration, initial value of I will be 3. J loop will go from 4 to 8 and so on. Are you getting this? So the loop of j will be for j is equal to I plus 1, j less than n, j plus plus. Because every time it should go till 8. Every time it should go till 8. Then what we do here inside, we check. What we do inside, we check whether 17 is less than 21. This is what we check, right? Whether 17 is less than 21, correct? So 17 is nothing but a of j. 17 is nothing but a of j for us. That we check with a of mean. That we check with a of mean because we have assumed now mean to be 0. So we check whether a of j is less than a of mean. We check whether a of j is less than a of mean. Whether 17 is less than 21. Yes. So if at j if we find a smaller number, we are going to update the value of j. Now our new mean will be j. Correct? Initially my mean was 0. Now my mean will become 1. Initially my mean was 0, but now my mean will become 1. Again then j gets incremented. Value of j will become 2. Correct? Again we'll check whether a of j is less than a of mean. Now what is j? It is 2. Whether a of 2 is less than a of mean. What is mean right now? It is 1. So whether 16 is less than 17? Yes. So it will come inside. Again we'll make our mean as j. So mean will become 2 now. Mean will become 2 now. Again j will be incremented. Value of j will become 3. Again we'll check whether a of j is less than a of mean. What is j now? 3. Whether a of 3 is less than a of mean. What is mean now? 2. Whether 9 is less than 16? Yes. So mean will become j now. Mean will become 3. Now next time when you proceed, j will become 4. Correct. You will check whether a of j is less than a of mean. Whether a of 4 is less than a of 3. No. So you will not come inside your if loop, and in that case your value of mean will not change. In that case your value of mean will not change. So how the code will look? Here we'll check if a of j less than a of mean. So if the number that you check is a smaller number, then you are going to update the value of mean. You are going to update the value of mean. Is this for loop understood, my dear students?
Yes, sir.
Yes,
Yeah.
sir.
Yes, sir.
So the outer for loop is for the number of iterations. Correct? It will go for n-1 iteration. In every iteration, we assume the first number of that iteration to be the smallest number. So we make mean is equal to I. And then we'd start checking for all other numbers. So from I plus 1, we'll start that checking till end. And if we find a new smaller number in that j index, we'll update the value of mean to j. Now, once we complete this j for loop, we will be in a position that we have found mean, right? So once this for loop will finish of j, this mean will be calculated, which we have written in the Excel on the right hand side. That is 3, 6, 8 and so on. Once we find this, we have to perform a swap. Once we find this, we have to perform a swap. Swap is happening between whom? I told you earlier also. It is happening between a of mean and a of I. In the first iteration, it is between a of mean and a of 0. In next iteration, it is between a of mean and a of 1. Then in next iteration, it is between a of mean and a of 2 and so on. Correct? Now also we should understand this, my dear students. Now see here, in some situations, already that smallest number was present on the same location, as it happened in case of 17. If you see the this particular step, if you see this particular step, which I have highlighted right now. So what was happened in this case? Your mean got calculated as 6. Your mean got calculated as 6, right? Now, does it make sense to swap a of mean with a of I? Because mean and I are same. Are you getting this example, what I am trying to explain, students? Sometimes what happens, the mean that you get and the I that you have are same. What mean I got? 6. And what is I right now? It is also 6. So does it make sense to swap 17 with 17? I don't need to write those 3 statements, right? That temp is equal to something and then copy back and everything. Only when this min and I are different. 3 and 0 are different numbers. So I did a swap. 6 and 1 are different numbers. I did a swap. 8 and 2 are different numbers. I did a swap. 7 and 3 are different numbers. I did a swap. 5 and 4 are different numbers. I did a swap. 8 and 5 are different numbers. I did a swap. In case of 6 and 6 and 7 and 7, the last 2 steps, already the smallest number is present in its appropriate position. So I don't need to execute those swap statements, right? So if the value of min and I are same, no need to do swap. But if the value of min and I are different, again I repeat, if the value of min and I are different, then we need to go for swap. And that swap will happen between A of min and A of I. That swap will happen between A of min and A of I. So let us write that here in the form of code now. So after we write this for loop, if I and min are different, right? If I and min are different, they are not equal, means there is a need of swap. The moment you find them to be equal, you will not come inside this loop, and in that case swap statements will not be executed. So here we'll write the swap statements. Now the swap will happen between A of min and A of I. So I'll write the swap statements for those. So initially I copy A of min into temp, then I make A of min as A of I, and then A of I as temp. Now this swap will only happen between A of min and A of I if the value of I and min are different. So when you come in this iteration, which I was explaining of same, that is value of min is 6 and value of I is 6. So 6 not equal to 6, this condition will fail, so that swap statements will not be executed. This completes our logic for selection sort. Did you understand, students?
Yes, sir.
Yes, sir.
Yeah. So before this you will take input array A, okay, and after this you will print the array A, which will give you sorted result. That thing you can try on your own now. So this completes the logic for selection sort. When it comes to the complexity, my dear students, here also we are dealing with two for loops of size n. So complexity of selection sort is n square, and n square number of comparisons, same like bubble sort. Because the philosophy is moreover very similar in case of bubble sort and selection sort. The only thing is bubble sort works on largest numbers and selection sort works on smallest numbers. So with respect to number of comparisons, both complexity gives an upper bound on n square. Both sorting techniques gives an upper bound on n square. Because in case of bubble sort, the problem gets reduced by 1 from right hand side, and in case of selection sort, the problem gets reduced from left hand side. Bubble sort works on largest number technique, selection sort works on smallest number techniques. So both gives you two nested for loops which are working on some parameter of n, and that's why both the sorting techniques is having upper bound of n square as their complexity. But my dear students, if we see the literature, it is seen that bubble sort is quoted as the worst sorting technique. Bubble sort is quoted as the worst sorting technique. If we see the time complexity of bubble sort and selection sort, what we see here is that both are having n square complexity. So we may feel that both are equal in nature. Bubble sort is n square and selection sort is also n square. So we may feel that n square is equal to n square, and that's why bubble sort and selection sort are having equal complexities. But no, my dear students, bubble sort is quoted as worst sorting technique. So we can say that selection sort is little better than bubble sort. So on what basis we tell this? See, my dear students, if you remember, in case of bubble sort, swap used to happen every time in each iteration because we were performing a push. Correct? Every time we used to check that number whether we are finding a greater number, and we were performing a swap, and we were trying to push that number to the rightmost position in case of bubble sort. Right? So the number of swaps that were happening in case of bubble sort were more in each iterations as compared to selection sort. If we observe selection sort, how many swaps do happen in each iteration? At most one. How many swaps will happen in each iteration? At most one. Why I say at most? Because sometimes swap may not happen also, like it was in the case of number 17 and 21 in our example, because in that case min and I both were calculated as 6 and 7, right? So if at all the swap happens, it will happen only once at the most in each iteration in case of selection sort. But if you remember, in case of bubble sort, we were performing that swap in each iteration many times, right? So though the number of comparisons remain the same in case of bubble sort and selection sort, but if I dig more into the analysis of these two sorting techniques, and if I also think of quantifying the number of swaps that I do make in case of bubble sort and selection sort, I can finally comment that bubble sort is the worst sorting technique, and at least selection sort technique is better than bubble sort. You understand, my dear students, the comparison between bubble sort and selection sort? So which sorting technique is better amongst the two? Yes,
Selection sort.
selection sort. Why? Why?
Less iteration, only one iteration in one step.
Not
Swapping.
iterations,
Swapping.
swapping. Iterations are same, right? So on the basis of number of swaps that happen in each iteration, we may comment that selection sort is better than bubble sort technique, because in selection sort we have at most one swap in one iteration. Why it is? Because due to pick nature in the solution, we are picking actually here, we are not pulling, right? Whereas in case of bubble sort, there are multiple swaps happening in each iteration due to push nature in the solution. So is this paragraph understood to all my students? How did I compare this bubble sort and selection sort? Overall, if I look at the number of comparisons, both looks same, n square. But when both things are same with respect to the number of comparisons, we did more analysis. That if I consider the amount of work required to do swap also, then here we get some distinguishing factor between the two. And on that factor, we comment that bubble sort is the worst sorting technique and selection sort is a better sorting technique as compared to the bubble sort technique. Is it clear, my dear students?
Yes, sir.
Shall we move ahead with the next sorting technique now?
Yes, sir.
Are you finding this sorting techniques interesting or is it boring?
Interesting.
Only one student is finding it interesting, it seems. We have 50 plus students in the classroom. We have 50 students in the classroom. Is it interesting, students?
Yes, sir.
Yes, sir.
Yes, sir.
Is your mic available in your phone? Chalo, all of you do an unmute. Let's celebrate. All of you do unmute. Let the panic happen in the classroom. I am not bothered. Is it interesting, students? All of you do
Yes, sir.
unmute.
Yes, sir.
Yes, sir.
Yes, sir.
Yes,
Yes, sir.
yes, sir.
Yes, sir.
Nice.
Yes, sir.
ऐसा आवाज क्यों
Yes,
नहीं?
sir.
Okay, very good, students. See, these topics are really important. So I want you to focus a lot because I again repeat, these topics are very important for your interviews. Okay, when you will be giving campus interviews, these sorting techniques, searching techniques will be asked a lot. So we should understand how every iteration happens and how the problem actually gets solved and how to compare between the two sorting techniques. So I wanted to make it more effective for you people so that you can remember the technique for a long period of time. So my appeal is that you also try to practice more examples. See, code are very small, right? See, code are very small, but in order to write this code, we should be able to solve multiple problems of same type again and again, so that our confidence will increase. So try to take some random numbers and solve a bubble sort. Try to take some random numbers and solve a selection sort. Once you start solving on the paper, then the logic runs in your mind, and then writing code is becoming very easy. Some students directly focus on writing code. That will not improve your programming skill. You should first play with numbers. Whatever exercise I am doing, this is in Excel, right? We should play with numbers, so we will come to know that what number is going at what location. Then we will think what kind of I need to write for this, what kind of j I need to write for this, and then we should go for coding. Okay, so with this, now let us move on to the next technique, next sorting technique, that is insertion sort. Next sorting technique, that is insertion sort. Next sorting technique, that is insertion sort. My dear students, insertion sort also has a phenomenon of executing in iterations. So here also we have n minus 1 iterations. So there are n minus 1 iterations. Okay. Now what happens in each iteration? What happens in each iteration is basically the main logic of insertion sort. Okay. For that, let me explain you that this particular insertion sort technique is very similar to that of a game that we play, that is playing cards. I want to understand that how many students from our classroom play cards. How many of you play cards? You can unmute and you can. How many of you play cards? No one? Is it? Not a single student from our class knows how to play cards. Yes, students, am I audible? Am I audible?
Yes, sir. Yes, sir.
Was my question audible to you people?
Yes, sir.
Yes, sir.
My question was, how many of you are able to play cards? Cards. You want me to tell it in Marathi or what? पत्ते पत्ते खेळता का? पत्ते किती जणांना पत्ते खेळायला येतात? No one? Don't tell me, then I cannot teach insertion sort then. Not a single student in the class? Yes? Hello, am I audible, students?
Yes, sir.
Yes, sir.
I again
Yes,
repeat,
sir.
I will not move ahead unless and until you answer me. You don't tell me that from 50 students in the class, no one knows how to play cards. पत्ते खेळायला येत नाही कोणाला? कुठल्याही प्रकारचा गेम येत नाही
I
पत्त्यांमधला?
know, sir.
मग
I
बोला
know,
ना.
sir. I
हा.
know, sir. Yes,
So,
sir.
yes, anyone else? Only 3-4 girls are now opening up. Boys, you don't play cards?
Yes, sir.
Yes, sir.
अरे मग कधी बोलणार आपण? प्लेइंग
Yes,
कार्ड्स
sir.
म्हणजे प्लेइंग कार्ड्स, ह्याला इंग्लिश बोलतो आपण, राईट? इट इज लाईक प्लेइंग कार्ड्स मीन्स आपल्या मराठीत आपण म्हणतो पत्ते. कुठल्याही टाईपचा गेम असो तो. साधा ते म्हणतो ना आपण, तो भिकारी बनवायचा तो गेम असतो ना, सगळ्यात सोपा, लहानपणी शिकवतो. ते तरी ऍटलिस्ट यायला पाहिजे ना, बाकीचं काही येत नसतं. Okay, so I assume that at least 50% students might be knowing playing, because unless and until you have that in your mind, understanding insertion sort becomes difficult. See, when we play cards, I don't know how I'll teach this particular thing. Let me try to connect my webcam. Okay, let me try to do it today, because I want to show you something, but just hold on for a moment, student. Just hold on for a moment. Am I visible, students?
Yes, sir.
Asa disto mi. Okay. So are you able to see my screen or you are able to see my face like cam? What is the situation at your end?
By default, screen is visible. We can
By
see.
default screen is visible, but okay, for a moment then I'll stop screen sharing so that my cam will be visible to you if I'm not wrong. Is my cam visible now?
Yes, sir.
Yes,
Alone
sir.
or you are able to see thumbnails?
With thumbnails.
With thumbnails. Oh ho 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 ho. So how to make it full then? This is, see, technology is very, at least you are able to see my face, right? That much.
Yes.
Yeah. See, when we play cards, see this is my hand. When we play cards, how we usually play uh, any type of game with that we try to play. So someone is trying to first shuffle the cards and then distribute amongst the people who is playing that game, right? Then we pick a particular card. Okay, when we pick a particular card and then we place that card in our hand. Correct? We place that card in our hand. So suppose if I pick a card and if it is a 5, then I keep that 5 in my hand. Correct? Then next time suppose I pick a card and if that card is 8, what I do? I compare that 8 with 5. That happens in our brain. I compare that 8 with that 5. And then I place that 8 on the right hand side. This is what we do, right? Then again if I pick 7, again if I pick a 7, again if I pick a 7, then what I do? I compare that 7 with that 8. I again compare that 7 which is there in my hand with 8. Then I feel 7 is small. Then again I see that 7 with respect to the first card in my hand, it is 5. So I come to know that it should go in between, right? So I place that 7 in between. So I have 5, 7 and 8 in my hand now. Are you getting this? Again if I pick and if I get a 2, then I check 2 with 8, small a, 2 with 7, small a, 2 with 5, small a. Then it goes on the left hand side. Are you getting this? Now whatever I do this in playing cards is nothing but insertion sort. Whatever I do here in the playing cards is nothing but insertion sort. Now my problem is divided into two parts in insertion sort. Already sorted and unsorted. Already sorted and unsorted. What is already sorted? Initially I'll pick my first card and I will keep it in my hand. Right? That is my sorted part initially. And what is my unsorted part? All the cards which are there on my table. That is n minus 1. Initially one number is already sorted. Right? One card is by default sorted. Right? And remaining n minus 1 cards are unsorted. Are you getting this? After I apply my logic, all will become sorted. Nothing will remain in unsorted. That's what we do. So for that, how many iterations we need to do? N minus 1 iterations. Why? Because n minus 1 cards are there on my table which are yet to be solved for sorting. So number of iterations that I will take will be n minus 1. Number of iterations that I will take will be n minus 1. Did you understand the philosophy of cards and how do I relate it to insertion sort? We have to see numerical and we have to see the logic also. But did you understand the philosophy of playing cards? Because that is what we are
Yes.
going to do in insertion sort. No doubt in cards we have 4 types of cards. Okay, that thing is also there. While playing, again we have diamonds and spade, all heart, everything. We have 4 different types of cards, but as of now you don't focus that. Imagine that you only have hearts and you're collecting that hearts, right? And then you're applying a sorting on it, and you're applying a sorting. So whatever we do while playing that card games in aligning the cards in our hand, whatever we do is actually insertion sort in real life. Is the philosophy understood? So insertion sort, as I told you, works in n minus 1 iterations. Okay, works in n minus 1 iterations. So I'll go back to my screen sharing now. Okay, with the philosophy statement. There are n minus 1 iteration. Problem is divided into 2 parts, sorted and unsorted. Initially, first element is by default sorted. What is the initial first element by? Are you able to see the notepad?
Yes, sir.
Yes, sir.
And you're also able to see video on the short one, if I'm not wrong.
Yes, sir.
Yeah. So initially first element is by default sorted. What is that first element which is by default sorted? The first card that I have picked up in my hand, left hand. Correct? So that is by default sorted, right? And all other n minus 1 elements are initially unsorted. And all other n minus 1 elements are initially. So we are going to apply n minus 1 iterations for these n minus 1 elements, right? So in each iteration, what we do in each iteration, my dear students, I pick one element from unsorted elements. Correct? I pick one card from my table. In every iteration, what I will do, I'll pick one card from my table. So what is technical conversion to it? I'll pick one element from my unsorted elements, and I'll try to place that unsorted element into my sorted list by applying some logic. Technically, I call that logic as displacement. Now here we will not do swap, because that card which I have picked up, that card may go at any position. So in the first example which I quoted you, the first number that I have in my hand is 5, and later on if I pick up a 8, then it will go on right hand side. But if I pick up a 2, it will go on left hand side. And suppose if I am having 5 and 8 in my hand, and if I pick up a 7, then it will go in between, right? So as my iteration will progress, I'll have more number of cards in my sorted list hand, right? So placing an element from an unsorted list will require a displacement. So I need to create some space in my hand wherever that card is supposed to be added in my hand, right? So the operation that we use in case of insertion sort is technically referred as a displacement operation. It is technically referred as a displacement. Here we are not doing a swap, like in case of bubble sort and selection sort. Are you getting this? Okay. So there are total n minus 1 iterations. The problem is assumed to be divided into 2 parts, sorted and unsorted. Initially, the first element is by default sorted. All other n minus elements which are there in on the table are initially unsorted, right? In each iteration, we pick one element from unsorted list. We pick one element from unsorted list. खालनं table वरनं आपण एक number उचलला, एक card उचलला, right? In each iteration, we pick one element from unsorted list and place it in sorted list using displacement. So what word that we should use in our write-up or while giving the oral or interview also is displacement. Here no swapping. Here no pushing, no pulling, no picking. Here we do a displacement. Now how technically we do a displacement? numerical for that with help of logic. I'll tell you in the next lecture. What is the philosophy statement understood, my dear students? What is the philosophy statement here? There are n minus 1 iterations in insertion sort. The problem is divided into two parts, sorted and all the remaining things that are there on the table unsorted. Initially first element, first card is by default sorted. All other n minus 1 elements are initially unsorted. In every iteration, now we'll have n minus 1 iterations for n minus 1 unsorted elements. So in every iteration, we'll pick one element from unsorted list and we'll place that element in the sorted list using the operation of displacement. If we do this for n minus 1 times, all the numbers will be sorted. All the numbers will be sorted. Is the philosophy statement understood, my dear students, for insertion sort?
Yes, sir.
Yeah.
Yes. Yes, sir.
I'll take the example on Excel and the logic in the next lecture. We are already running additional time, so let me download the attendance. Just hold on, students. I'm downloading the attendance. Let me stop the recording also.